In this video, we're going to discuss Kirchhoff's current law. Now there's two versions here, version A and version B. I think version A is easy to understand when you first see it. It says that the sum of all currents entering a node is the same as the sum of all currents leaving a node. So let's suppose you have a circuit here, and we've got a node, and we've got three branches off of this node. And let's say that we have 5 amps entering from the left, and then we have some amount of current, we'll call this I1, going right, and some amount of current going down, I2. Well, then what we are guaranteed is if there's 5 amps coming in, whatever charge is coming in is going to have to leave somehow. So some of it's going to go in I1, I2, but together that has to equal the total amount coming in. Or in other words, the amount coming in, 5, is equal to the amount going out, I1 plus I2. Now version B, it seems to be a little bit stranger. It says the sum of all currents treated as leaving a node is 0. However, it is mathematically the same thing, and to see that, let's suppose again we have our situation here. We have our I1 going right, we have our I2 going down. But as you see here, it says we want to treat every current as leaving the node. So this 5 amps that was coming in, we're going to treat it as a current going out. But again, based on how things work with positive and negative, anytime you go in the opposite direction, it's just the negative. So 5 amps coming in is the same as a negative 5 amps coming out. And if we now add up all the currents going out, we'd have negative 5 plus I1 plus I2, and it's supposed to equal 0 here. And you can see if you move the 5 over, you get the same equation that we already had. So you see version A and version B, they are mathematically equivalent. Version A, I think, makes more sense initially, but version B is the one we're going to be using in future problems, because in a random circuit, a lot of times you don't really know what current's actually going in or what current's actually going out, and so you just draw your labels however you have them. And if you just want to be consistent, you can just always treat every current as leaving a node when setting up your equation like this.